Hello. I recently made a video claiming that the kinetic energy formula, famously known as 1/2 mv squared, was wrong. So that created a bit of a firestorm, and it has inspired me to improve my experiment. So let's take a look at my new setup and, for example, how I do the measurements. Welcome to version 3.0 of the kinetic energy experiment. So the first one I used a cardboard ramp and only got about 2 data points. The second experiment used another cardboard ramp, but I only got 6 data points. And the problem is that we need a heck of a lot more data points than that to be able to tell the difference between v squared and v. So I've got this set up. I've got my Hot Wheel track, fresh from the dollar store, and I've got my new little red car here, okay? So we've got 30 feet of track, and I can measure how high this is, although the height really doesn't matter. This is just a way to launch the car in a reliable fashion, so I can collect as many data points as possible. So you can see how far that went. So this is how I do my measurements. First, I've got my video here and I wait for the car to go by. Then I back it up, single stepping. Then I align my post-it to the end of the blur here. Advance it 4 frames, 1, 2, 3, 4. Align this once again to the end of the blur. Then I go and I measure what this is in millimeters. So that is 108 millimeters. I write that 108 in my chart. Then I wait for how far it went. So I had to go walk down and then read off the tape measure. 13 feet, 10 inches. So 13 feet, 10 inches. And that's how I get my measurements. So here are the new results. So instead of 6 data points, we now have about 87 data points. With the velocity difference range ranging from 160 to about 9. So what can we notice about this data here? Well, one significant thing is that this can't be plotted on a straight line. So like we have this line here, about the straightest line we can plot through it, and it pretty much misses every single point on it because this is so obviously a curve. Now, I did get a very handy hint from Minty Mints. He said that if you have a XY scatter plot like this, you can have Excel actually figure out a matching formula for it. So I can just hover over one of these data points here, and it'll say format trend line. And then I can have it, for example, generate a matching exponential line, and obviously that doesn't match, or a matching logarithmic line, etc., etc. Um, so what we have here is that there are various ways to make things match up. And so if we were to try and see whether this corresponds to a v squared. So on the bottom here is the velocity, and over here is distance traveled, or is a proxy for kinetic energy. The Excel spreadsheet trend line says that it's about v to the 1.89. So that's kind of close to x squared, but it is significantly missing a lot of the data points. So it undershoots here and it way overshoots up here. So it's not really x squared either. So in some ways, this is still showing that the kinetic energy formula, at least from this experiment, still isn't right. It's still not matching 1/2 mv squared. Now, curiously enough, the trend line which matches it closely, fairly closely, is what is called a polynomial, in which case it's a form of x squared plus some factor of x. So this line matches fairly closely. So what does that mean? I'm not quite sure what it means. Now, it could still be, as Gary says, that friction is lying to us, and that if friction were perfect, and if the distance traveled exactly reflected the kinetic energy, that I don't know, maybe this line would straighten itself out. But maybe not, or it may be with a reason why this isn't fully x squared is also because perhaps there is some nonlinearity with the distance acting as a proxy for kinetic energy. So I'm trying to come up with some other experiments to show, what is the extent of, say, that effect. And that may include, for example, presuming that I could measure the launch height of the car, and presume that that is the input amount of energy, and then see whether that has a linear relationship to the distance traveled. That would be one way of doing it. My previous experiment, it kind of looked that way. There seemed to be a very linear relationship between the height and the distance traveled. But once again, that was only 6 points. Now, the problem with only having 6 points is that if you're down here at this lower speed here, like this section here, that can look fairly linear. So, if I only plotted those points there, below about 40, that you can draw a pretty straight line between those guys. And this is kind of what we saw in the previous experiment, that with so few points, there were only like 6 points, and it was like in the under 15 difference in velocity, that it can look pretty linear. This is why you have to do more experiments. So I actually did this twice completely differently, and with different velocity ranges. So my second one was kind of like this, and this looks a bit closer to x squared, but it's still it's really still overshooting down here at the end here, so not quite x squared, but it's definitely not say mv, which is momentum, right? And with this a variety of data, you can directly test to see whether doubling the speed, quadruples the kinetic energy. So I can pick like, say we've got 25, and that measured out at 12 and 12 and 3/4. So so it should, so at 50 it should be 51. So, and we've got what, like 49 here, and so it's 49. So it's fallen short, is what it's doing. So it's not quite x squared, which is what this is showing, is that it's x squared is generally overshooting what is actually measured. So once again, I'm not exactly sure what to make of that. That could be an effect of friction. But once again, the point of this series of videos is to just show how you can do experiments, and to show that you can actually do an experiment that's trying to directly test whether the kinetic energy formula is true, because this whole thing was motivated by the fact that there wasn't any videos on YouTube that actually tried to directly measure the kinetic energy formula by just measuring the velocity and then trying to find the proxy for the kinetic energy. In my case, I used how far the car travels, presuming that it loses energy by friction at a constant rate, which may or may not be a correct assumption. But here's the data, and once again, I appreciate all the comments and all the ideas. And we will be continuing this on with another series of experiments to see whether, for example, friction is lying to us. So, but that's all we have for now. Ta ta.